Hello everyone. How do we feel about weeds? For this next session about weed science, I want to explore why do we worry about weeds. We're going to talk about their identification, classification context. We're going to talk about the spread of weeds, history of weed control, biodiversity, weed ecology, reproduction and dispersal, allelopathy, and understanding weeds. So why do we worry about weeds? Well, clearly the first reason is their economic impact. They can create difficulty in harvesting, and when we undersow our spring crops with our diverse lay, sometimes the weeds, or the intended weeds in that situation, so the diverse lay is a sort of, you can view it as a weed, but actually we're replacing what weeds they are with intended weeds. And so they can grow quite strong sometimes and create a challenge for combining. But what we find is that as long as the sun is shining on the crop, the combine can cope with green material at harvest time. But as soon as the sun sets or the clouds come over, then we have to stop. So even when we've got a large amount of green material, we can still cope with harvesting. Difficulty separating saleable crops, so we can have contamination in the crop, that something like wild oats, where it's difficult to separate them. It can reduce yield perhaps, and it can taint the food. Sweet clover in malting barley, the seed of sweet clover can taint the malting barley, so you don't want that to happen. Some weeds can actually be toxic in the food or forage. So ragwort, I've got a picture in a couple of slides' time of ragwort. I guess you have that in Estonia as well. It's a yellow flower. If you've got it standing in a field, then the animals won't choose it, so they'll ignore it and go round. It's only toxic if you cut the field for hay or silage and mix it up with the forage, because then the animals can't select it themselves. So we might think about the future impact of weeds. There's a saying in English, 1 year's seed is 7 years weed, for good reason. The visual impact. So as I mentioned, my mother saying, I don't want to be looking out of my bedroom window at a field of weeds, and I'm sure some of you would have the same feeling. So there's a human need for order and control. My father always said that you never want to be a roadside farmer, because everyone's going to be driving past and going, tut, 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 you've got weeds in your field. Actually, it's exactly what we've done. We've actually bought a bit of land next to the road, but we're much more confident with our farming system now that I don't mind having it on display for our neighbours. So sometimes there's an environmental impact of invasive weeds. So tall grass is a particular problem close by us. We have a site of special scientific interest. So it's a site next door to our new farm, which hosts rare and delicate wildflowers, but they have an invasive plant there called tall grass, which it's okay to graze in the spring, but if you let it get old, then the cattle won't eat it because it's very spiky and not very palatable. So, and that's been coming into our land as well, but we're managing it with grazing. So interesting, in English, there's the word weedy means weak and feeble and frail. Yet not all weeds are weedy, weak and frail, and perhaps as organic farmers we wish they were, and then we wouldn't have to worry about them so much. So we like the weak and weedy ones because they can add to our biodiversity perhaps. So just to think about yield for a minute and reduction in yield. Are we looking for a maximum yield or an optimum yield? What else has an impact on crop yield? So clearly the amount of sunlight. We didn't have so much sunlight this year. It's a very wet season for us, and less warmth. That will affect the amount of growth from plants. Soil quality will affect plant growth, fertility, rainfall, soil moisture holding capacity, and competition from other pests apart from weeds. That's a map of our soils on our farm, the subsoils, and you can see the variability of the soils over our farm. So that's clearly going to have an impact on the potential for our crops. Where you've got the darker soils is the heavier, more clay crops. So here's some research done by several people here, looking at the yield loss from weeds. And what they found is that generally yield loss from weeds is perhaps exaggerated, and we think of it as being, weeds as being more impactful perhaps than it is in reality. And that's why I say about it's more a case of the type of weed that's in our crops, and we perhaps would be good to focus on that. And as the quality of the soil improves, we tend to get those less impactful weeds naturally. So yield, it's about quality versus quantity and volume. And I often get asked what the yield of our crops is on our farm, and I'm always, to be honest, reluctant to answer, because for me it's about having low costs, not about having high yield. It's about having high quality so that we can get a better price, maybe a premium price. I'm reluctant to use the word premium because that gives the impression that some people perhaps can't afford it, and we want to make organic food available for everyone. But it's about getting a premium so that you can use it for bread making, for example, rather than just for animal feed. So it's making more use of it. So it's quality rather than quantity, I would suggest. It's also about what you're giving up. If you're having this high yield, what are the consequences for that? What are the impacts? What are the unintended consequences of having this high yield? Perhaps poor soil, lack of soil function, so future fertility. I could see the quality of our soils decrease, and I was wondering how we're going to grow crops in the future as a result of my previous farming techniques. And if you're damaging the soil, you then get exposed to these stronger, what I call pioneer weeds. So the weeds that nature sends along to recover the soil. And disease and pests are also more likely when you have these higher stressed plants, one which is fed through the soil water. Clearly those are more open to disease. So what else does a field yield? So it yields food, clearly, but also these public goods and services, and can yield nature as well. And I think they're all important contributions. So we saw this image before, so I would suggest that this is one of the unintended consequences of achieving higher yields is soil degradation. Just one. So a weed is a plant that has a perceived, I would suggest, negative impact on a human being. So we say beauty is in the eye of the beholder. It's subjective. So we classify weeds essentially as monocotyledons or dicotyledons. So monocotyledons are the grasses, dicotyledons are the plants that produce two first leaves, whereas the grasses that produce one single first leaf. So it's an easy way of splitting them up to start with when they're just emerging. We can differentiate them into perennial and annual weeds. Volunteers is another type of weed. So seedlings emerging from previous crop residues, so where you've got seeds, cereals that go out the back of the combine and they're left on the floor. I'm sure you're all familiar with the term volunteers. And then I use this term pioneer weeds, and we'll talk about that more being the weeds that go into difficult circumstances and recover the soil for nature. So we need, I clearly like this word context, we need to think about context of weeds in both time and space. So whether it's in our home garden, in the lawn, alongside a road, or in building sites in city, weeds that come up after a wildfire in woodlands, are those weeds? And of course in different situations in agriculture or horticulture. And sometimes a weed is a weed in one context, but actually it's a valuable plant in another context. So the spread of weeds. So weeds spread through seed purity or impurity. Bought in seed, I've had it here when years ago when I bought in some seed and it came with wild oats in it. And I was a conventional farmer at the time, and they offered to give me some wild oat spray. I was clearly a little bit naive at the time to kill the wild oats that I'd brought in with the seed. To this day, I'm still suffering the consequences in that field, so I wouldn't do that again. Don't plant weed seeds accidentally or on purpose. That's not a good idea. So how do we as farmers spread seed? Well, our harvesting equipment clearly can spread the seed, so we're careful to clean our combine harvester off after each field. That's just routine. Cultivation equipment can spread seed, so we have lots of mud on a cultivator and you take it to another field. Clearly, if you're taking the soil, you're going to be taking the weed seeds with you. And irrigation is an interesting one. I've heard of situations where irrigation can spread weeds very effectively as well. Natural processes that spread weeds, so birds, wind, water, and fur. That was the inspiration for Velcro, which holds our coats together sometimes, or our shoes even these days, if we don't have laces. Weed seeds can be there from as a legacy from an earlier time, and this is where often you find the pioneer weeds establishing. So you're thinking, oh, where did that weed come from? I don't remember there being them there in the past. Some weeds or some weed seeds have an incredible ability to last long periods in the soil. Wild oats certainly for years, perhaps decades. I've heard of some plants possibly lasting several decades. So number 5, weeds respond to fertility. So if you're particularly NPK, so there are certain crops, so we've got cleavers, gallium aparina on the left bottom, that responds to nitrogen fertilizer particularly, and wild oats on the bottom right also respond to nitrogen fertilizer. There you can see the yellow flower of ragwort. So some disease and some predators will restrict the spread of weeds, and you can see the dock beetle there, which is eating the docks and perhaps stopping them flourishing as much as they might. And there's a caterpillar that only lives on ragwort. Some weeds are thought to be injurious or invasive. I already talked about invasive ones, and it's a very pejorative term, so it's leading us to think that weeds are bad. So these injurious weeds are generally what I would call the pioneer weeds. So I'm thinking them from their point of view. You know, nature sent them along to repair the soil. So docks, spear thistles, creeping thistles, and couch. And many pioneer weeds are triggered to grow after wildfires. But also we need to consider that these pioneer weeds also have their time. There's an interesting book by Isabella tree called wilding, which documents an estate in England that's gone through a process of, I think it was about 2,000 acres. They fenced the boundary, they stopped producing crops, they let the land revert naturally to a wild situation. They do now, they shoot deer on the farm, so they have quite a large income from shooting deer on the farm, and they also have cattle on the farm, but they're allowed to roam freely. And what they found is that some of these weeds tend to come and go, and their experience with thistles was exactly this, that the thistles fulfill their purpose in nature. They repair the soil in whatever fashion it was that they were sent to repair, whether it was compacted or whatever particular issue it was. And then you'd find that they start to recede and other plants are favoured. I was speaking to a friend only last weekend on his farm in just south of here, and he was having the same experience where he'd reverted a conventionally farmed field to pasture, and he could see different parts of the field that had been treated differently in the past and how they were slowly repairing themselves and recovering, and the species of plants that were growing naturally in that soil was changing over time, how the pioneer weeds were suddenly disappearing, docks in particular in this case, and the grasses were being favoured. So what I'm saying is that weeds demonstrate there is a problem, and there's a little scale there. It's a demonstration. You're not going to be able to see the detail. Actually, that's a document about 10 pages long, I think, looking at lots of different species of plant, what situation they're favoured in, what environment, what soil type, what whether it's acid or alkaline soils that favours their development, and so on. So what it is, if you see them, what conditions you can expect. And wildflowers, what do they indicate? And just as an analogy, you know, when we went through the coronavirus, a global pandemic, it was spread by travel, globalization, population pressure. We could say it was a monoculture of people causing this spread, and we have exactly the same thing with superweeds. And also, as an analogy, Denmark has a quarantine for wild oats. So if you have a wild oat in your field, by law you need to remove it. So they have a protection in their fields. So the recent history of weed control. So IPM is integrated pest management, and it's one of the subjects I lecture in at university. So what we're doing is, rather than just blanket applying chemicals, we're looking at specific techniques. Why have these problems, pests, emerged? So why have some of these weeds become dominant, even flourished in modern systems? So weeds have become resistant to herbicides. In the UK, black grass, a particular type of grass, has become a real significant problem in conventional farming. And when you're growing, when farmers are growing genetically modified crops, which are resistant to Roundup, to glyphosate, this can then lead to superweeds, so weeds that are then resistant to all pesticides. Understanding weeds tell us pesticides will eventually fail. This is my predecessor at Reading who says this. So he's a researcher. He spent his whole life researching weeds. This is also what my father said when he was introduced to organic farming, and we were at that early stage of changing from conventional and how much organic were we going to go, were we going to convert the whole farm. My father said, yes, I can see the old way of this old way we were farming before he couldn't see it continuing. So soil degradation will lead to weed-specific environments, and again, I go back to the pioneer weeds, but there's also a group of weeds called polygonums, which are favoured in low pH soils. And if you're using artificial fertilizers, clearly you end up with low pH soils. Human health, I would suggest, is also part of the history of weed control. There's been many cases in the United States that have gone to court, particularly in California, around the use of glyphosate and operators being ill as a result of their use of pesticides. And even the World Health Organization labels glyphosate as probably carcinogenic, i.e. cancer-causing. So there's a link to that video again about glyphosate. History of weed control is also about environmental health, and I refer back to Silent Spring by Rachel Carlson. It was written in 1962. So that also the socio-economic impacts on human health systems. So the NHS as our National Health Service, what impact those pesticides have and the degradation of soil has on our personal health, how that impacts water companies as well. And there's two particular pesticides which are causing issues with water companies locally around here. Biodiversity. So what is biodiversity and why is it important? And I think one of the concepts I've come across in the last few years is this idea of the shifting baseline syndrome. And I think it's important when we are having an overview of these ideas. And what it means is that the baseline shifts from one generation to the next. So if you were a farmer in the 1950s, for example, you saw a particular shift in something. Maybe it was the number of trees on your farm. And maybe a disease came along and reduced the number of trees, and the government paid us as farmers to remove some of the hedgerows and some of the trees on our farm. And so you saw a reduction in the trees. The next generation came along, and their baseline is the ending point for the previous farmer. So they've already got a low point, but that's their starting point. And then they might see a degrading of the baseline. And so for the next farmer that comes along, the baseline falls a little bit further. But what they don't see is where the original baseline was to start with. And this shifting baseline syndrome is about remembering any degradation that happened in previous generations that we haven't seen. This is a video about the economics of biodiversity, which is another excellent video I would recommend for you to watch. It was a review that was carried out by, or paid for by the UK government, and carried out by a Cambridge economist who looked at just from economic terms, the costs of the loss of biodiversity around the world, I think it was. And why is that important? Well, when we look at, I mentioned early on that 40% of global land is occupied by farming. If we look at this slide here, we can see that farming is much more intense in some countries than it is in others. And if farming excludes biodiversity, so it only employs monocultures, where is it that nature is going to live? And I hope as organic farmers we have a sense that nature is important. If we don't have nature with our farm, then we don't have places for the predators to live. The possibilities for pandemics increases. where you're in a monoculture situation, as we experienced with the coronavirus. So when considering weed control, do we only consider food production? What is the difference between biodiversity and weeds? When are weeds not biodiversity? And the unintended consequences of removing weeds. There are hosts for insects, pollinators, food for farmland birds, and food for soil biota. The role of uncultivated land in pest and beneficial insects. So this is another University of Reading professor, Van Andel, who retired about 10 years ago now. He was writing about this in the 1960s as well. So the value of uncultivated plants has also been known for a long time. Increased above ground biodiversity leads to increased below ground biodiversity and vice versa. So if we have crops with weeds in, then we're going to increase the quality of our soil. Increased biodiversity leads to increased carbon sequestration, and that's the paper I wrote recently. So that paper talks about landscapes that work for people and biodiversity. And this is the paper which talks about how if we have a diversity of weeds, then we can reduce our crop losses from weeds. So it's particularly looking at small uncompetitive weeds that then fill the soil profile, and by filling the soil profile with those uncompetitive weeds, it means that you're not encouraging other weeds to flourish. And here I just wanted to talk about a concept of land sharing or land sparing. It's a concept that came out of South America not that long ago, but it's then been used completely out of context. So in South America, it was used in order to spare the rainforest. So the idea was, okay, well, we'll farm this bit here and this bit over here, this part of the rainforest we won't touch, and we'll leave that pristine. But then someone in Europe got hold of the idea and thought, oh, well, we can apply that to modern agriculture. We can farm the hell out of this field, but without a bit of, we'll allow nature into a corner of the field over here. So we can spare a bit of land for nature. The problem with that is that pollution from the bit you're farming intensively doesn't stay in that intensively farmed area. It leaches either through the soil water or through migration of insects into the bit you spared for nature. So the idea is flawed, I would suggest. What we need is land sharing. Land sharing is we allow nature into our fields as much as we can, but still grow crops. So we're letting the cattle into the woodland to increase the biodiversity in the woodland. We're letting the weeds into our fields so we don't have a monoculture of cereals. And we're having a diversity of cultivars in our cereal fields, and maybe even a mixture of cereals. So last 2 years we've been growing mixtures of cereals for a distillery. So barley and wheat we grew 18 months ago. This year we grew rye and wheat mixture for a distillery in a specific situation. So it was, and they grew together really well, and clearly there's lots of benefits to be had in that situation. But it's finding the opportunity, of course. And so Regionaal is a researcher from California, I think he, rather than sustainable intensification, which was a term coined in England to try and work in this land sparing idea, he said what we need is ecological intensification instead. So more biodiversity, essentially. So weed ecology, I think as farmers, we need to put ourselves in the shoes or roots of the weeds, understand how they grow from a biological point of view, the study of their life systems, their physiology, their phenology, their cycles, and how they grow in the seasons. And by doing that, we can then understand how the weeds interact with their environment. We can understand what it is they're trying to show us, and perhaps we can favor a situation that we want rather than they're trying to indicate, and improve the situation for our plants rather than a weed that perhaps doesn't suit us so well. So we need to see this from the weeds point of view, and that's why I call those difficult weeds pioneer weeds. It's seeing them as what they're striving to do. So invasive weeds, what is it, why, and it's good to understand why they are invasive, because then we can understand their mechanisms. There's a weed called Japanese knotweed. So Japanese knotweed is an imported weed that has become prolific in gardens and on the sides of riverbanks. So it's very competitive. It spreads via its roots. Also, if you cut up the top of the plant and it spreads by an insect or a bird carrying it, it'll grow again from the top plant. And so it's quite difficult to control, but by understanding how it works, by storing energy in the root, you can then control it by burning up that energy, and then you effectively kill the root. But if you don't burn up that energy, it'll just use its innate ability to grow again, to carry on. So you have to understand what specific, unique, competitive advantage it has. Have weeds become worse? Well, I would suggest that it's all about perception, of course, and the situation, and where you have, go back to this, I've already shared this research with you, the effect of fertilization. So if you have high nitrogen situations, then certain weeds will flourish in that situation, like the cleavers, the little furry round seeds. And if you've got compacted soils, there are certain weeds that are going to flourish. That's what they're there for. So weed species change with fertilization. And also, in the same way, climate change will have an effect on weed species diversity. So we're seeing that weeds are smart. They are indeed, and we're going to talk about weed reproduction and dispersal. So seed, they clearly can reproduce by seed. Seed numbers are interesting. If we look at docks on the left-hand side, that's the genus Rumex. They are perennial. They reproduce from root or seed, and they'll produce up to 60,000 seeds per year. On the right, we have wild oats. This is in a field of beans, and the seeds, in fact, in this situation, have already shed and they're all on the floor, but they're producing up to 2,000 seeds per year, so large numbers of seeds. So we talked about the spread of seeds above in 5. What's particularly interesting is the indeterminate nature of seed maturity. So I'll just explain what that means. So with a wild oats plant, what you have is seeds that don't all mature at the same time. And if you look at wheat and harvest wheat, of course, they all mature together. That's what makes them a successful domestic crop. But many weeds don't mature all their seeds at the same time, and that's what makes them a successful weed. Because in a wild oat plant, some of those seeds will fall to the ground before harvest, and some of them will still be in the plant once the crop has been harvested, so they end up either going through the combine harvester or they end up in the seed and contaminating the crop. But it also means that some of the seeds are falling at different times, which may produce different beneficial advantages, or the early seeds may be in a good advantage and the late seeds not, and then in another year vice versa happens. So that indeterminate nature of seed maturity is often important for weeds. And I think it took me a long time as a farmer to understand the difference. When you're growing a domesticated crop, you put it in the ground and you expect it to grow. So you expect it to germinate. So that's the germination bit, because there's no dormancy. So most domesticated crops don't have a dormancy. You put them in the ground, good conditions, moisture and warmth, and off they go. But weeds often have a dormancy, which can be very frustrating for us farmers, because take wild oats, for example. If we put a bunch of wild oat seeds into the ground, we might expect them to grow. But actually, only about between 40 and 60% of any of the seeds at one time would germinate in any particular year, unless there are extreme positive circumstances. But generally, you get that sort of level of germination, because not all the seeds will break their dormancy in any one year. There's lots of different triggers for breaking the dormancy, and it's difficult to know what those triggers are. So dormancy and germination, when we're thinking about weeds, we need to understand the difference between dormancy and germination. There are specific signals for dormancy. So docks, for example, rumex, their dormancy is broken, in my experience, from compacted soils. So when our cattle have been out in a field and squashed the soil, that triggers germination. So longevity, age, how long they last in the soil, and their interaction with other species. So fungi, for example, fungi can wrap themselves around seeds and then prevent dormancy from breaking. But if so this has been found with wild oat seeds, if the fungi encase the seeds, they can last much longer. But if you cultivate the soil, it favors a little, it's called a mesofauna colembula, a little critter, a little bug that lives in the soil, which will eat the fungi and then release the dormancy of the seed. So there's a lot of complicated things going on with regard to the length of dormancy and the germination with seeds. So we can look at the life cycle and the weed seed bank. And here we have the wild oat life cycle. I know you could figure out a life cycle for any weeds that you're particularly interested in. And so at the top, we have the surviving plants, and 90% of their seeds end up as seed production. And we're going down the center here. I don't think you can see where my arrow is pointing. And 40% of those seeds end up in the soil. 60% of those seeds are either empty, inviable, or end up in the combine harvester. And then you carry on round the cycle. A lot get lost to decay and predation, so insects eating them, and then you get a number of 60% eventually germinating the following year. So that leaves 40% still in the soil for future years. So just by having a year when you don't crop and continually cultivate the soil, you're not going to get rid of all the weed seeds. And that brings me on nicely to weed seed bank management. So it's those seeds that have been deposited in the soil for a rainy day. It's the 1 year's seed that becomes 7 years of weed. because the seeds don't all germinate in the same year. So how do we manage that? And if you can read the little box, the table that I've got there, you'll see that actually there are enormous numbers of weed seeds that are held in our soils. And I would suggest that trying to reduce that weed seed bank is almost futile, almost a waste of time. So we need to have systems that cope with the weeds, and then we're not trying to remove the weeds. That's certainly the approach we have on this farm. So we're trying to cope with the weed seeds that are there, because there's so many that are asleep in the soil, we're never going to remove them all. So weeds also reproduce from roots, from rhizomes or taproot, perennials, and these tend to be what we call the pioneer weeds because they have multiple ways of reproducing. So they store energy in their roots, we talked about that before, to enable them to regrow at another time. Just to be aware that as farmers and gardeners, we send them signals all the time. So some of our actions will naturally trigger the dormancy in our seeds. So they switch off and they think, oh, you know, they're smart. And they think, oh, well, the farmer's doing this. You know, they've worked with farmers for thousands of years. So they have been specialized into farming situations. So they'll go to sleep when we're tilling the soil, and sometimes they'll just wake up when the soil has moisture again. So we need to be careful how we're working. As my predecessor said, know that enemy. I think that's a little bit strong, but I think you get the point. You need to understand the biology of the weeds in order to favor the crops you want to grow. Allelopathy is a difficult word to pronounce, but it's about the plant's defense mechanism. So the roots of the plant send out signals. They might send them out through the mycorrhizal fungi or just as root exudates, and they can inhibit germination of other seeds around them. So part of our strategy on our farm is to make sure that the crops are establishing in the whole soil profile, so they can fill the seedling roots can fill the soil profile with roots as quickly as possible, because then that will switch off the weed ability to germinate. However, post-harvest residues of wheat, so straw from wheat, can actually stimulate germination of some weed seeds. What other defenses do plants have against weeds? Shading. So if you shade the soil, then that can prevent germination of some weed seeds. And I talked about fungi and their interaction with crops. So understanding weeds, hopefully we now understand weeds a little bit more than we did. And if so, we can now try to manage them a little bit smarter, maybe even outsmart them. We can maybe appreciate them a little bit and even select the ones we want. We can know their reason for being, so why they're there. We can understand why nature has sent them into a particular environment. We can understand their mode of action, but also understand their weakness. So how do we feel about weeds now? Do we feel weeds have a value? So this is the view from our combine harvester, and that's it looks like a crop of wheat, doesn't it? But I think it was actually spring barley. And we can see that weeds can provide food for soil biota, food for birds, food for insects. They provide a species richness. They add root diversity. They can provide nutrition for cows and for wildlife. they can aid soil recovery? Well, sometimes. Maybe some of them are welcome. Good. Well, thank you very much for listening.